Alright guys, what is up? This time. Last time we did building a circuit until it is aesthetically pleasing. And now we're going to build a circuit until it is the ultimate rat's nest where you can't figure out what the fuck is going on or um if anything's going on at all. So to start off this, we will be completing the dance circuit that we had left over from the other day, and we will be moving into the NOR and eventually figuring out how to do these stupid fucking 7-segment displays. Amazing. So, we will try to get started if I can even recognize where I left off from, which unfortunately right now I'm having a hard time struggling to try to recognize. This is okay, let's remove this wire. It's obviously too short. So instead cut out a new wire that's a lot longer and takes up a lot more unnecessary space. Perfect. Wire is down and we can continue circuiting. This will be C and or no, that's going to be A and B. I think I've been wiring my entire thing wrong. Let's see now. I'm building a NAND circuit for a school project. So I'm trying to figure out what step I'm on, and I'm a little bit lost. So just have a little bit of patience because I am pretty new to breadboarding, and it is a school project, so it's a little bit difficult, but I'll try to work through it. I can see these two wires are C and D, and from C and D I routed it to over here this way, so these two are C and D combined, which I need to connect to an inverted A and B, which is inverted A and B would be right here. So I would need to connect that using another NAND gate, and we would be cutting some new wire to do that. So I'll get out my wire cutter. To this one works. Actually, from this side over to here, and then we would take another wire, the output of the NAND gate from my C and D onto my A and B. Let's strip out some wire. doing so good now. Okay, so we plug the output of that into I need to be converted into C and D combined into another inverter. So inverted C and D, which be these two. They should go over here. And that should continue inverted A and B circuit. I think I would be restarting because I cannot figure out what's going on, and I think I built this circuit completely wrong. So we will be needing to restart, but that's okay. It's not that many wires. It's because I marked my inputs and outputs wrong. So well, we'll be getting a fresh start, and we'll be testing the full effectiveness of a rat's nest. So that's fun, I guess. This time I'll try to make it a lot more clear. But we have A, B, C, D. So I'll be first dragging out my do them one by one. So we'll use this side for this is very confusing. Switching out these wires for something a little bit better. Okay, so we have our switch 1, which will be, or switch 0. This will be that would be D. So D would be towards over here, and then we have C would be one less. Then we would have B. Finally, we would have our A. So we've pulled out all the inputs, so we can start linking them to wherever they need to go. So since I will be using these NAND gates over here, I'd like to link them across the board, so then they wouldn't need to travel an extremely far distance. So there we go, we linked up our D. Now we would link up C as well, because both of it needs to travel across the board. I think that wire is bad, so we will just swap a wire. This wire is too short. It's okay. So will be run nesting. I will be cutting my wires down properly. However, general rule of thumb is you want to keep your wires flush to the board so you know what is actually going on. And I will put up an image of what I'm building. Okay, there's an image of what I'm building now. So it might help some of you guys understand, but it's a very simple NAND circuit. I'm just having a little bit of trouble. So after that, we can start connecting our gates properly. So and I'll use the bar one. I'll just swap these two around, I guess. A little bit. Okay. Using the close ones for my A input, and I'll be using the far ones for my B input. So we can actually kind of stay organized, even though it is a rat's nest. It'll be easier to troubleshoot later on. For A, this here, and then we would plug another wire from A into this NAND gate, so then we can invert it properly. And then we would plug in A, and then we'll take it to another NAND gate. So by doing that, we would take a white wire, because this is from A, we would put it into the slot right next to it. And then we would try to attempt to plug it in if the wire wants to cooperate. There we go. Now it's plugged in. Now we would work on red, which I don't have any red wire available, so I'll be stripping a new set. I won't plug into the board to try to find the exact distance, because we are trying to save time. So the red wire is in. We bend it down a little bit. Now we would get the second red wire, because we need to invert a second B as well. So grab another red wire, strip it, plug it somewhere into the board, and onto the input of NAND gate number 2. Okay, we finished up that. Now we need to connect the NAND gates to each other by having the output of NAND gate number 2 go into the input of NAND gate number 3. This way we can allow it to communicate properly. So we can take the wire and connect it to output of the inverted B into the input of C, and there we go. This is now completed. Now we can wire this output into another NAND gate, because it will need to also be connected with C and D as well. So we connect it to another output. So, or connected to another input, sorry. So with this wire, we can see the output goes to the input of another NAND gate. So that's ready to go. And now we can start working on the second the second thing that A and B has to do. So we need to connect 1A with 1B. To do that, let's first try just the wire. If the wire would go in, okay, there we go. And then we'll connect it to a NAND input. Perfect. And then we would take a wire here. We will connect it to input here as well. There we go. Have it connected. And those two are done. Now we just need to invert this one. So by inverting this, we would take apart one red wire and connect it to the NAND gate right next to it. So there we go. We have connected it. And now we just need a second wire to connect again because we're inverting it. So we will strip out a second wire here. And after stripping out the second wire, we can plug it in to right over here. And there we go. That's both of them done. And they will go into another NAND gate, which we will just take the output of this NAND gate and plug it into the input of another NAND gate so we can wait on the others to be completed. So now we've completed A and B, so we will move on to C and D. So there we go. The rat's nest is starting to come together. So for C and D, we'll start off by inverting each one. So we would be taking C over here to the far side of the board. Okay, this wire is just really messed up. Same with this one. So guess we'll be stripping new black wire. Yay. If this wire will cooperate. Alright. So we will take this off. Take off a little bit more. And strip it. And take it over here to this side. And we will take the same thing again because we need to invert it. So 1, 2. Be the second one. Inverted. Inverted. There we go. And then we will also need to invert our green wire as well. So we'll be taking this wire here, connect it from here to over here. And we'll be taking a second green wire and connect it from the same spot as we're inverting, and same input to same input. Now we have it inverted, then these two would actually combine in a NAND gate. Interesting. So we would take one green here into this place right here. We would put over a green wire. Get in. Okay. So the output of these two will actually go back to with the input of another wire we already did previously. So we just need to connect the output into the input from our half completed NAND gate earlier. And now this output can go into the input right next to it. My hands are small enough to actually grab out the gate. You can see we put the wire in. There we go. And finally, we can continue with our building for C and D, which we need a gate for C and D to merge together. So we would be taking one C and plugging it into, let's see, this gate here looks like ideal choice. And then we would be taking another black wire, which I do not have. So we would take apart from my very long collection of wire and it's tangled right now, so let me just untangle it really quickly and we would be able to put it on the board. Okay, alright, that took only a little bit of time. I've untangled the wire. Amazing, right? So we take apart this, we would take that apart too. I'd be able to connect this to over here. Now we have that combined, and we just need to put that into another NAND gate in order to invert it. How amazing! So inverting yet again. Let's connect it to the top sides to over here, and we would need another one. I don't have a short wire, so we would be using a long one. The rat's nest. We have freedom. Okay. Alright, and those two has been plugged in. So we need to take the output of that and put it into the input of this gate that was left unfinished over here. So we would do that by grabbing a wire and plugging that into the input. This gate here, wire would fit in. Stupid wire would go in. There we go. And now that's plugged in. So finally, we just need to combine the last two in yet again a NAND gate. So we have the output here, this one. And by plugging in these two together, I should have completed all the logic necessary. and we only need to plug in the LED to the final one, and we should see an LED light on. So we would need a longer wire, so let's strip out some more black wire. We'll be plugging into, how about G1? G1 looks like a good choice. Okay, so now we can grab our power source, plug it in, and see if my cable can reach. My cable does not reach, so I'll test it and let you guys know what happened to it. Um, it doesn't work. To sum it up, it does not work. So let's go through troubleshooting, guys. Why does it not work? A and B. So I've decided that we are instead going to be fixing this breadboard because it's a lot less work than trying to figure out what the happened to my other one. So we would just be replugging in some wires just to make sure that it's not because of a wiring issue. So I'm just going to grab some wires and try to fix it because this one caused a lot less of a problem than my other one, which was a pretty big issue. So my other breadboard just didn't want to work at all, and this one at least has only a couple of minor issues that are generally not too hard to fix. So I will just be rechecking this breadboard instead of completely using the other one. So this breadboard, we're plugging in both the outputs of B or inputs of B in, and it looks like it's okay. I'll just be replacing these white wires as well. Because those white wires did not want to work properly, I think. So we replace it with properly used ones. It might work a lot better. This spot, and we need another white wire. So, here to that one. Okay. Now let's change think that one's okay. Now let me go test this again. Unfortunately, something is still wrong, which now I would figure out off stream. That's gonna be it for today, guys. This was not very successful, but I'll see you guys next time.